Railway track construction. Building a railway track is a complex and highly specialized process that requires careful planning, engineering expertise, and adherence to safety standards. Below, I'll outline the general steps involved in building a railway track. As the most important part of railway track system, railway track plays a role in giving a reliable surface for train to run. Railway track have other names like railroad track, track and permanent way. Railway track is simply a type of metal rail for train. There are also highway guardrail and industrial railing system. Since the first track building in the 1825, railway track go through several reforms. Ballasted track and ballastless track are typical types of railroad track. In general, railway track consists of ballast bed, steel rail, railway sleeper, railway fishplate, rail clip, railroad tie plate and other railway fasteners. How to build a railway track with all these components. Here is the guide to introduce the process step by step. Pre-construction activities. There are some preparative works before railway track construction. Project planning and design. Conduct a detailed survey of the proposed rail route to assess factors like topography, soil conditions, and existing infrastructure. Develop an engineering design that includes track alignment, gradients, curves, and other specifications. Consider factors such as the type of trains to be used, e.g. the freight, passenger, required track gauge, and expected traffic volume. Land acquisition and clearing. Acquire the necessary land rights for the railway corridor. Clear the land of vegetation, debris, and obstacles that may interfere with construction, earthworks and grading. Excavate and prepare the subgrade to create a stable and level foundation for the track. Build embankments or cuttings as required to maintain the desired track alignment. Among all the activities, subgrade drainage and materials preparation are common. The subgrade drainage is a system that is used to prevent railway from waterlogging. The subgrade, roadbed and slope of railway track are very easy to be washed by water. If the subgrade drainage measures are not proper, this will lead to the subgrade diseases. It is necessary to install drainage before laying the track. Specifically, it mainly adopts drainage pipes, carrier drains and attenuation ponds in some area. The preparation of construction materials is another work before track laying. Ordinary materials include railway sleepers, steel rail, rail fasteners, and some construction equipment. Preparation works primarily refer to check the complement and integrity of all materials. When all preparations are ready, next step is laying the bottom ballast. Laying bottom ballast. Ballast bed is the dependable foundation for railway track. According to the construction procedures, ballast bed construction is divided into two parts, bottom ballast and top ballast. There are other procedures between bottom ballast and top ballast laying. So, bottom ballast and top ballast will be separate to introduce. Set the thickness of bottom ballast by the design. Track design for main track is double track. Bottom ballast is made up medium coarse sand. Spread the railway sleepers. Put sleepers on each side of railway track equably. Laying railway sleeper on the track manually. Keep the central point of railway sleeper and rail track centerline in alignment. The bottom ballast is transported to the track and unloaded equably as planned. The compaction is realized by manual spreading and mini road roller. Railroad sleeper. Railroad sleeper is an important railway component. It is also well known as railroad ties and mainly used in the railway fastening system to ensure the correct position of the gauge. During the past time, they were most made of wood, which should be rich for the large requirements. But considering the short useful life and large wood consumption, wooden sleepers have been gradually replaced by concrete sleeper on the main trunk. In order to resist longitudinal and transverse displacement, the railway sleepers should have some essential features such as firmness, elasticity, durability, or easy to fix, etc. In other words, when the train passes, railway sleepers can be suitably deformed to buffer the pressure. But after that, it must be recovered to the original shape as soon as possible. How to lay railway sleepers. Laying procedures of concrete railway sleepers. The concrete sleeper is widely used with its features, which include long useful life, good stability, can satisfy the requirement of high speed, large capacity, etc. The laying method of concrete sleepers as follows: Pre-construction activities mean going through the relevant formalities, testing pull-out forces of anchoring, choosing the rails and equipment will be used during construction, the safety regulations of sleeper handling and loading. The highway transportation of sleepers should use vehicles with a fixed frame, and the vehicle should be compatible with sleeper size. The number of layers in the load is less than 6. Sleepers should be lashed tightly after loading to prevent any movement in a seaway. The railway transportation of sleeper should load according to the loading plan that was approved by Railway Department. Construction of broad sleeper railroad. As an important part of track, ballast bed is the foundation of the track frame, which has the follow functions: with the pressure from sleepers and pass to the subgrade surface evenly, provides elasticity of track, reduce and absorb the impact of the wheel rail, provide a good drainage performance, so that improve the bearing capacity of the subgrade and reduce subgrade diseases. The exact construction steps as follows: cleaning and earth excavation of ballast bed. Subgrade surface was crushed by vibratory roller, generally 8 to 10 times is appropriate. Detecting density by using density tester, and it should be detected qualified before laying coarse sand cushion. After laying coarse sand cushion and crush it again, then lay sub-ballast and top ballast zone. The thickness is 250 mm. Laying of sub-ballast is generally divided into 2 layers. Crush it after laying a layer to ensure the compaction. Criteria for compaction: thickness is not less than 250 mm. Top ballast zone: use hard wearing gravel, which must ensure the good quality. Thickness of laying is over 5 cm. It should be smooth after laying, but cannot have wavy or twist irregularity phenomenon, so as not to affect the length. Of concrete sleepers. Laying of concrete sleepers: place square wood pads under sleepers for enough strength, and anchor locally. Concrete sleepers can be laid after finishing construction of top ballast zone. Notice that both ends of the sleeper should fall on ballast zone steadily, so as not to affect the structure of the ballast bed. As for control piles, they are usually nailed on the both ends of the sleeper, and control the distance between 2 piles strictly. The spacing of sleepers must be managed well. Rail gap is the same. Some tips about laying concrete railway sleepers: ballast must be distributed and tamped before laying sleepers. When pre-laid ballast is in trouble, in situations in which protect sleepers from damage, lay sleepers first, and lay ballast. Watch out the center of sleeper overlap the center of line as far as possible during laying sleepers, so that reduce the movement of sleepers. There must be rail pads between rails and the sleepers as buffer layer. After the completing the laying of new concrete sleeper railway, at least 1 to 2 times tamping comprehensively before it is officially open to traffic. And reduce the speed, strengthen the observation of the railway, find the problems in time and get quick solution. There are mud pumping, uneven subsidence, cold damage on the roadbed, or ballasted bridge that lay wooden sleeper, and ballastless bridge that has an abutment with block ballast wall. In these cases, concrete sleepers cannot be used. Anchorage means the process that fix railroad spike to railway sleeper. This procedure requires materials as follow: sulfur, sand, cement, paraffin, screw spike. Laying steel rail laying mainly include rail apolegamy and track laying. Rail apolegamy is a necessary process in the track laying. Measure the length of each rail, and rail apolegamy can be based on it. It is suitable to use rails with same length deviation. What's more, length deviation is less than 3 mm, and cumulative deviation is less than 15 mm. Rail layings start from the rear end of turnout. The length of non-standard rails can be determined by the location of insulation joints. Convey steel rails by the monorail vehicle, then lift them to rail ditch manually. When steel rails are placed, connect them in railway sleepers by the rail fastening system and rail components like rail joint. Rail anchor and rail brace. Rail anchor is used to prevent track from crawling. Rail brace is connected with steel rail through rail bolt and nuts. Both rail anchor and rail brace are designed to keep steel rail in place and ensure the rail safety. Alignment and gauge check. Use surveying equipment to verify that the track is correctly aligned, level, and within the specified gauge. Make adjustments to the track as needed. Ballast tamping and packing. Use specialized equipment like tamping machines to compact the ballast and stabilize the track. Maintain proper track geometry and prevent irregularities. Track surfacing and super elevation. Adjust the track's super elevation, banking, and curvature to allow for safe and efficient train operations. Ensure proper clearances, including overhead wires or structures, electrification and signaling, if applicable. Install overhead catenary wires or third rails for electrification if the railway is electric. Install signaling and communication systems for safe train operations. testing and commissioning, conduct thorough testing of the track, signaling, and electrical systems to ensure they meet safety and performance standards, train operators and maintenance personnel on track operations and safety protocols, regular maintenance, implement a scheduled maintenance program to inspect and maintain the track, sleepers, rails, and associated infrastructure to ensure safe and efficient operations. Building a railway track is a complex and resource-intensive endeavor that requires the collaboration of various engineering disciplines and adherence to safety regulations. The specific procedures and standards can vary depending on factors such as the location, type of railway, e.g., high-speed, freight, and local regulations. Therefore, it's essential to consult with railway engineering experts and authorities when planning and executing such projects.